Have you ever wondered how databases are structured and designed? Welcome to the world of ANSI SPARC architecture. This conceptual framework, developed in the late 70s by the American National Standards Institute, Standards Planning and Requirements Committee, has become a cornerstone in understanding and designing database management systems. This architecture, also known as the three-schema architecture or three-level architecture, presents a tri-level view of databases. These levels are the external, conceptual, and internal levels, each serving a unique purpose and playing a pivotal role in the functioning of a database. Let's start with the external level, also known as the view level. Imagine it as a custom-tailored view of the database for individual users or applications. Each user interacts with the database through these views, which can hide certain specifics of the underlying data structure and offer a personalized perspective. Moving a step deeper, we encounter the conceptual level or the logical level. This level provides a unified, logical view of the entire database. It's here that the logical structure of the database is defined, independent of any specific physical implementation or user views. Changes made at this level affect the entire database, yet they remain unseen by the users at the external level. Diving further into the core, we reach the internal level or the physical level. This level is all about the nitty-gritty of how data is physically stored and organized within the database system. It focuses on optimizing data storage and retrieval performance, ensuring data integrity, and managing system resources efficiently. The beauty of the ANSI SPARC architecture lies in the clear separation between these levels of abstraction. This separation allows for data independence and modular design, meaning changes made at one level have minimal impact on the others. This facilitates system maintenance, evolution, and scalability. Understanding these three levels helps us to comprehend how databases work and how they are organized. So next time you interact with a database, remember you're navigating through layers of complexity, all thanks to the ANSI SPARC architecture. Now imagine you are an end user of a database. What you see and interact with is the external level. The external level, also known as the view level, is like a custom-tailored suit. It's designed specifically for you, the user, and your unique needs. It's your personal view into the vast ocean of data that lies within a database. But it doesn't just throw all the data at you. It curates and presents only what you need to see, keeping the rest hidden away. Think of the external level as a filter. Each user or application interacts with the database through this filter, which is carefully crafted to provide the most relevant and necessary information. This filter is called a user view. It's like your personal lens into the database, showing you just the data you need in a format that makes sense to you. But here's the beauty of it. There isn't just one lens. There can be multiple user views, each uniquely designed for different user groups or applications. So the marketing team might have a view that focuses on customer data, while the finance team might have a view that zeroes in on transaction data. Each view is tailored to the specific needs of its users, providing a customized perspective of the database. While the external level may seem simple on the surface, it plays a critical role in the ANSI SPARC architecture. It's the gatekeeper of data, controlling who sees what and how they see it. It ensures that users are not overwhelmed with unnecessary details and can focus on the data that is relevant to them. However, the external level also maintains a level of abstraction from the underlying data structure. This means it can adapt to changes in the database without affecting the user's interaction or view, providing a level of stability and consistency. So, why is the external level important? It's all about user experience. It makes interacting with the database intuitive and efficient by presenting data in a user-friendly and meaningful way. Remember, the external level is all about the user's perspective of the database. Moving a step deeper, we find the conceptual level. With that, we delve into the core of the ANSI SPARC architecture. This level, also known as the logical level, is the heart of the system, providing a unified logical view of the entire database. It is a level that is independent of how the data is physically stored or how it's presented to individual users. Think of the conceptual level as a blueprint of an entire city. This blueprint doesn't concern itself with individual buildings' interior design. That's the external level's job. Nor does it care about the materials used in construction. The internal level takes care of that. Instead, it gives us a bird's eye view of the city, showing us how everything fits together. The conceptual level defines the logical structure of the database. This includes entities, attributes, relationships, and constraints in the database. These are typically represented using a data model such as the entity relationship model or the relational model. For instance, consider an online bookstore database. The entities might be books, authors, and customers. The attributes could be book titles, author names, or customer addresses. Relationships could be author writes book or customer buys book. Constraints might include rules like each book must have at least one author or customers must provide a valid email address. All these elements come together to form the conceptual schema. A crucial aspect of the conceptual level is that any changes made here affect the entire database. However, these changes are transparent to users at the external level. For example, if we add a new attribute to a book entity, like publication year, the users won't be affected unless their views are updated to include this new information. The conceptual level, therefore, serves as the bridge between the user's view and the actual physical storage of data. It's the level that ensures the database is logically coherent, while also maintaining a level of independence from both the user's perspective and the physical data storage. A well-designed conceptual level is key to a flexible, scalable, and efficient database system. Finally, at the heart of it all lies the internal level. This is where the rubber meets the road, where theory becomes practice, and where data is physically stored and organized within the database system. Think of it as the engine room of our database ship. It's the place where the nuts and bolts of data storage and retrieval come to life. Here, we're concerned with the practicalities of how data is physically stored and organized. It's not just about filing away data in a logical structure. It's about doing so in a way that optimizes performance, ensures data integrity, and manages system resources efficiently. Imagine your database as a library. The internal level would be the equivalent of the library's physical layout, the shelves, the storage rooms, the cataloging system. It's here where we decide on the best way to store and retrieve our books, or in this case, our data. This level includes details such as storage structures, indexing methods, access paths, and physical data representation. These are the tools of the trade when it comes to managing data effectively. Storage structures dictate how data is organized, indexing methods speed up data retrieval, access paths determine how data is accessed, and physical data representation is all about how data is encoded for storage. Changes at the internal level, such as indexing strategies or storage allocation, do not affect the external or conceptual levels. This is because the internal level is designed to be transparent to users and applications. It's like a well-oiled machine quietly humming away in the background, doing its job without disturbing the rest of the operation. This level of the ANSI SPARC architecture embodies the principle of data independence. Changes made here should ideally have minimal impact on the other levels, allowing for easier system maintenance, evolution, and scalability. The internal level is all about optimizing storage and retrieval performance, ensuring data integrity, and managing system resources efficiently. It's the unsung hero of the database world, working tirelessly behind the scenes to ensure that everything runs smoothly. So, we've taken a journey from the user's perspective right down to the physical storage of data. Let's take a moment to recap the key points and insights we've gathered along the way. We began our exploration with the external level, the user's window into the database. This level is all about customization, providing tailored views that suit the specific needs of various users and applications. It's a level of abstraction that hides the complexities of the underlying data structure, presenting users with only the information they need. Then we moved on to the conceptual level. This is where we find the logical representation of the entire database. It's independent of the specifics of physical implementation or user views. At this level, we see the entities, their attributes, relationships, and constraints. Changes here affect the whole database, but thanks to the magic of abstraction, they're invisible to the users interacting at the external level. And finally, we delved into the internal level. This is the realm of physical data storage and organization. Here we find the nuts and bolts of the database system: storage structures, indexing methods, access paths, and physical data representation. It's all about optimizing data storage and retrieval performance, ensuring data integrity, and managing system resources efficiently. And the best part, changes made at this level don't impact the external or conceptual levels. That's data independence in action. The beauty of the ANSI SPARC architecture lies in its clear separation of these three levels of abstraction. This modular design allows for changes at one level without disrupting the others, facilitating easy system maintenance, evolution, and scalability. This architecture may have been conceived in the late 70s, but it remains a foundational concept in designing and understanding database management systems today. Remember, understanding the ANSI SPARC architecture is fundamental to comprehending how databases are structured and designed. It's the key to unlocking efficient and effective data management.